But now we've gone more to the blends with the prebiotic fibers and the knowledge about soluble fibers and the ratios. We kind of know about that, those things for different life stages and so forth. I mean, not that we don't have a lot to learn. I mean, we do, but we're getting there where okay, how much fiber does a puppy need? Okay, after it's weaned, how much does it need? What's the ratio? And then go to the other end of the life, the aged animal, the geriatric, and the 15-year-old dog. How much does it need? Well, it needs different than what that puppy needs, right? And then if you have dogs with health issues like digestive problems of one type or another, or allergy problems or whatnot, the carbohydrate composition makes a difference.
Hi everyone, and welcome to the Pet Food Science Podcast, where we seek to discuss research from around the world and how it may apply to innovation in the pet food industry. I am your host, Julia Pezzali, and today I have the distinct pleasure of speaking with Dr. George Fahey and to talk about the past and future potential of fiber in the diet of dogs and cats. Welcome, Dr. Fahey.
Thank you, Julia.
How are you today?
I'm doing well. How about you?
I'm well as well. Before we start talking about fiber and all the amazing things you have done in the past years, would you mind telling us and our audience a little bit of our background and how you end up in the area of companion animal nutrition?
Well, I've been at the University of Illinois now for almost 46 years, so a long time. I finished my education at West Virginia University in 1976. I got my PhD, and I was hired in Illinois as a ruminant nutritionist. I had studied comparative nutrition, so but one of the species was ruminant species, and so I was hired here as a ruminant nutritionist, and I studied fiber for all of my research life, and so I continued that here, and so that was the major focus for probably 15 years or so. And then it got very difficult to obtain funding for research in ruminant fiber, in the fiber area with regard to ruminant nutrition. And so I had the chance, we had a companion animal program here that really involved teaching only one course. One person was teaching one course, so we didn't have much of a program, and the leadership of the department at the time wanted to get more into research, so they said, well, would you consider taking over the leadership of the companion animal program? So I had worked with Dr. Corbin before. He was the one that started the program, and I'd worked with him for quite a few years, but he had retired. And so he encouraged me to do that. And so this was in the, I'd say, mid-'80s or so. And so after some thought, I thought, okay, well, that might be a good opportunity. And it turned out to be a very good opportunity. So then I switched over completely around 1990, early 90s to pet and didn't do any more ruminant research after that.
No, that's great. I'm glad you accepted the transition.
I retired in 2010, but I was hired back right away to teach. So I really stepped aside probably in 2015 or so. And today I still serve on student committees and whatnot, do a little work at the university, but mostly do consulting in the pet nutrition space.
Tired of one-size-fits-all solutions that don't quite fit? At Wilbur Ellis, we're bringing custom back to the customer. We know that for your pet food and treats to shine on the shelf, you need to start with the best. After all, even the best recipe is only as good as its ingredients. From nutrition to preservation to blending and bottling, make one call to Wilbur Ellis Nutrition to find it all. We don't sell to you, we work with you. A true partnership to meet your needs. Follow Wilbur Ellis Nutrition on LinkedIn to learn how partnering with a purpose could double the power of your team.
I know, that's awesome. And I think everyone knows you, but for those who don't, maybe are listening from other countries, Dr. Fahey is always very active on the helping students and being in conferences and helping everyone. Yeah, so that's awesome. And I saw fiber was the connection between the transition from ruminant to companion animal. So do you mind sharing with us how was the first studies that you've done with fiber in dogs and cats, and what was the first thing you want to look at when we start studying fiber in companion animals?
Yeah. Well, there was a bit of a mercenary aspect to the change as well, because when the ruminant research funding sort of dried up, we had a student here at Illinois that had worked with Dr. Baker named Diane Hirakawa, and Diane went to become ended up being director of R&D over at IMES. So the IMES company had come on really strong, and their objective was to make the very best food possible. And Diane, they had a very good product, but she was interested in the fiber aspect of the diet. She had studied the human literature, and the human nutrition literature showed that fiber was important. And she thought, well, the same may be true for dogs. So dogs and cats. So she said, I will give you, if you will study this, I'll give you a fair amount of money to do these studies. So there was this mercenary aspect to it. I thought, okay, well, that sounds like we're off to a good start, because you can't do anything without money. And so what they wanted to study, interestingly enough, was beet pulp, because there was this kind of a general feeling that beet pulp was good, but people didn't really know why it was good as a fiber source in pet diets. So we proceeded to get into that. And the funny part about it is that, I had no graduate students the least bit interested in pet nutrition. They'd all been ruminant nutritionists. I was finishing all them up, and they weren't really interested in doing experiments with dogs or cats. So I myself, and I had a technician, and I hired somebody else. So we actually did the research that turned into 3 manuscripts that are published in Journal of Animal Science. And it's really the only 3 manuscripts where it says Fahey et al., because most of the time I always have the graduate students, they're the senior authors because they did the work, right? They should be the senior author. That's part of it. But there was nobody to write this up except me. So you'll see these 3 beet pulp articles in Journal of Animal Science authored by Fahey et al., because nobody else would write it up. So anyhow, that's how we got started. And then after that, we studied many, many different carbohydrates, fibers, etc. But as you know, Julia, the pet nutrition space is occupied by very few people overall. Way many more nutritionists of various species and human nutritionists than there are pet nutritionists. So you can't I learned very fast that you better step out of your fiber space, because you're asked questions about every other nutrient that animals need. So you have to kind of become one of these jack of all trades and masters of none, because you get so many questions about just all the nutrients. So we've studied over the years many, fats, proteins, minerals, etc. Always most interested in the carbs, but nevertheless, you still have to broaden yourself a little bit and study other things.
Yeah, that's great. So I assume fiber and carbohydrates your passion. What is your second, nutrient that you like to explore more? Is there any?
I don't think there is a second favorite, so to speak. I mean, another person that was my partner in crime when we started was Dr. Neil Merchant. Mm-hmm. And Neil was a ruminant nutritionist as well, and we worked together. He actually set up the course. He prepared the first companion animal nutrition course, really an excellent course. And he was a protein person. He had studied protein nutrition at University of Wisconsin in dairy cattle, and so he was obviously interested in that. So we began work with protein as well. We worked together in that. So, but to say you have a favorite, even to have a favorite, is probably not the best thing, because you just don't know what you're going to get into. You just have to kind of be a lifelong learner here and keep your mind open about. Today, of course, it's a lot about supplements and nutraceuticals and functional foods and all these types of things. And, you have to keep yourself educated in those to make a contribution,
Yeah, no, I agree. And I think the most important learning in grad school on your master or PhD is not even the subject, is how to learn to be a scientist, the techniques you learn, the people you connect, and having that truly mindset. So some people get attached, I want to work with this. No, you're learning how to be a scientist, and that's the most important part, I think, of grad school.
Yeah, correct.
So you talk a little bit about amino acids. Do you mind sharing with us how we start doing the work with ileocannulated dogs, and how that really helped us to kind of understand a little bit more about amino acid bioavailability and protein, and why we had to kind of step away over the years from that technique, and what other models have you also used and developed to get great insight on protein quality, amino acid adjustability, but also be less invasive on the companion animal area?
Well, when we were when Neil and I were in studying ruminant nutrition, we always had cannulated animals, and rumen duodenal ileocannulated animals oftentimes. And Neil himself was an excellent surgeon. He was fantastic, because those kind of surgeries, you have to do them right. If you don't, the animal, there'll be leakage and there'll be problems. But he was really good in that. And so we thought about, we'd like to get estimates just like swine people, true digestibility or standardized digestibility of amino acids. And so he said, well, and others had done this. Others had done ileocannulations on dogs. And so we did that, and it worked out great. I mean, the cannulations that he did were perfect. The dogs recovered very fast. They were very well taken care of. And so for quite a number of years, I'm not sure, maybe 15 years, we had a colony anywhere from 6 to 12 ileocannulated dogs to work with. And so we ran a lot of ingredients through those, because it was a unique opportunity to get this information. Not very many people, not very many others around the country were doing that. Kentucky, Dave Harmon was doing that at the time, and there was a person or two in Europe, but there weren't too many. And so we did a lot of experiments with ileocannulated dogs, and then got a lot of good data, had a lot of publications on that. So we had those until I retired. But as time went on, there was people looked askance at that. They didn't like the thought of surgically modifying dogs. And even though the dogs were in wonderful shape and very well treated and lived long lives, there was just this perception by the public that it wasn't a good thing to do. So people that followed me were not interested in continuing that. It was kind of a continual battle to try to justify these things, even though it was totally allowed from an IACUC standpoint, and from any regulatory body standpoint. It was allowed, but it just didn't have that perception of being something that we should be doing. And so we don't see that done very much anymore, if at all. I don't know of anybody that's doing that kind of work. It's kind of a shame, because it's a very good model. It provided the animals well taken care of, and provided the surgery is done correctly. It's very useful. But anyhow, it's just not on the table anymore. So we had a person in the department named Dr. Carl Parsons, who had been doing what they call cecectomized rooster assays. And this is an assay where they take the ceca, the paired ceca in the rooster out, and that's the site of almost all the microbial activity in the gut of the rooster. And so you can get the same kind of value. You can get quote unquote true digestibility or standardized, whatever you want to call it, because there's no microbial contribution to digestion. And that is a very popular model. It's gotten way more popular as time has gone on because you don't have the public perception of that being a problem. And you can get true metabolizable energy, TMEs, and you can get true or standardized amino acid digestibility values. And then you also can use the ingredient by itself. Instead of the dogs, you had to have a complete and balanced diet to be able to do the work. But with the rooster, you did not. We also paired up with Dr. Stein and others in the swine area at Illinois who have ileocannulated pigs. And so that's another great model. Now, of course, the pig has a big cecum. And so the data, the digestive physiology there is a little different than the dog. And so in some sense, the rooster is the better model, the cecectomized rooster. Is the model. So that's how we kind of evolved away from the ileocannulated dog to the cecectomized rooster or the ileo or duodenally cannulated pig.
Yeah, no, that's great. And there's a lot of the papers now that with the cecectomized roosters over the years and is great data to the industry. Do you mind explaining for those who are not familiar if they do a trial and get some digestibility data out of the cecectomized rooster compared to the total tract or parent total tract using dogs, what differences are they gonna see between those numbers and the importance of probably doing both so we can get the kind of ideal data on digestibility, but also in the animal, we're gonna really see the effect on the dog or the cat, right?
Yeah, well, apparent digestibility is just simply food intake minus feces excreted divided by food intake. So the big thing there is that you have the large bowel that has the microbiota that takes care of, that ferments a lot of the material that is coming out of the ileum. So the parent digestibility values are very valuable because that's really what happens in the animal. But at the same time, it's always good to know what the true digestibility is because that gives you a sense of that allows you to compare what's going on in the large bowel versus the rest of the digestive tract. And so like you say, the comparison is good. It's always good to have apparent digestibility studies. That's always quite useful. But then to have something like a true digestibility of an ingredient that is in the diet that's fed to the animal on the digestion test, that's really valuable. So it's helpful to know how to formulate and that type of thing. I mean, you can determine like what the contribution of the microbial protein is, or what are the microorganisms doing to the effluent that reaches them, and that type of thing. So it's both are quite important.
Yeah, and I think data only complement each other, so different techniques help us to understand the whole picture and take best decisions for sure. And you mentioned microbiome and microbiota. So how was the start of doing omics research and microbiome data out of not only the short chain fatty acids in feces? So how was the start of that in your program, and how did you see this transition and how it's been evolving over the years?
Well, back when and I'm not sure what the year was, but it became quite apparent that the microbiome was important, that the microbiota in the large bowel were important. And, that had been overlooked for so many years in non-ruminant. In ruminant nutrition, that was if you talked about anything, you always talked about the bacteria in the rumen, right? I mean, because that's the first, when the food drops into the reticulorumen, and so it's fermented first and foremost. So as a ruminant person, the microbiota had always been important. But not so much in other species. Matter of fact, I remember a seminar one time early on in my career when we were together, a big group were together, and somebody mentioned something that might be going on in the human large bowel, and several professors scoffed at it, like, oh, that doesn't make any difference. That, what possible role could those things have? Because they had no idea what was going on. But so we started doing some of this work back when, in the very early days when the technology was nowhere near what it is today. And I had a couple students back then, PhD students who were interested in studying that. And so I told them, I said, this is well beyond my area of expertise. So I sent them down to take a course in the microbiology department by a person that really had a great knowledge of this. And I said, you're the one that has to defend this. When your defense comes up and you don't know the answer to a question, don't look over at me because I won't know. I can tell you that right now. So they took a course or two. And so we started looking at this using that early technology when it was very expensive. I mean, you could get rid of $15,000, $20,000 with one plate or two, 1.5 plate. It was ridiculous. So a couple of the students started out, and then they some of the research that they generated was very interesting. Plus, we had then about 1995, the whole area of prebiotics became important. And then, of course, probiotics had always been kind of important, although, again, that was an area that animal nutritionists always were kind of nebulous. We didn't know exactly what they did. Was it important to feed a probiotic? Those types of questions. But then this prebiotic concept came out, and that, of course, directly impacted the microbiome. And so these students started that. But then the technology got so much better, and people like the group here at Illinois, Kelly Swanson, Maria de Godoy, they're taking this, they're studying this all the time now using the latest technology. But when my students started in it, it was really kind of at the front end. Technology was limited. It was very expensive, but we got the thing started, and then of course it's gone on from there. So, which I'm happy to see because it's really important to know these things.
Yeah, no, it's important to understand and to get this additional data as well, not only the product of fermentation, seeing this again, the whole picture of things help us to tell a better story. And when you're comparing ingredients or diets and how they play a role on gut health.
Yeah, and the other thing, that's come on now is this postbiotics. That's another term now. And the organization that really has helped us in this area is ISAP, the International Scientific Association for Pre- and Probiotics. The people in that are just top notch, and they're generating what I consider to be the very best data in this area. And they're providing the definitions, they're providing the strengths and weaknesses of technologies and all these types of things and interpretations. And they're very balanced. They're not like they're not really getting behind, oh yeah, you have to have a probiotic. No, they're very balanced in how they view these things. And I think that's really advanced the field.
Yeah. Are they more focused on the human side or is it more comparative?
They are. But I was on the board of directors for a while, and my job was to kind of be the animal, quote unquote, animal person. And there was some interest at the time, but actually, as time has gone on, there's been a little more interest. We just had a meeting in Denver last month that we had a whole animal section on postbiotic, prebiotics, postbiotics, and probiotics. And so I'm hopeful they'll kind of embellish on the animal work and promote that more.
Yeah. So for humans, there is some entities, organizations that they recommend, even though dietary fiber is not an essential or indispensable nutrient, there is for humans a recommended dietary intake per day, depending on the age. Do you think there is maybe some benefits of doing the same for our companion animals? And do you think we maybe over the years are going to move towards more a recommended intake of fiber depending on the age or life stage and talking about healthy animals?
I think we are kind of doing that now, maybe more informally than formally, because we do know a lot more about how fiber impacts the digestive physiology and the overall health and well-being of the animal. And so I don't know if we'll ever get to the stage where there'll be the requirement or the suggested values that we have for humans, but those of us in the field kind of know what the appropriate amount is and the idiosyncrasies. For example, you have to, like with soluble fiber, you have to be very careful with cats. Cats don't react well to a lot of soluble fiber, where a dog would have no problem. So those kinds of things. And it's gone way past the beet pulp thing. Beet pulp is still really excellent. And the reason it is because regardless of how it's been handled, whether it was harvested at the time the beet was harvested and protected from the weather, or whether it's set out in the North Dakota winter, for months, it still has this unique ratio of soluble to insoluble fiber. Okay, if a beet pulp has been protected, it can have a ratio of 50-50. It can have half of its fiber can be soluble. Now, most of it are not protected. And so you'll find that the ratio is 70-30 or 80-20, something like that. But it always has a fair amount of soluble fiber. And this is the kind of the key to the success of beet pulp. And, we can go back to even ruminant work. And if you show dairy cattle, for example, and you don't want them defecating, you're in the show ring and you want them nice and clean, a lot of times the farmer will feed beet pulp because it firms up the feces. And so there's these little tricks from ages ago that have been used, and come to find out it's because of its unique fiber properties. And so, but now we've gone more to the blends with the prebiotic fibers and the knowledge about soluble fibers and the ratios. We kind of know about that, those things for different life stages and so forth. I mean, not that we don't have a lot to learn. I mean, we do, but we're getting there where okay, how much fiber does a puppy need? Okay, after it's weaned, how much does it need? What's the ratio? And then go to the other end of the life, the aged animal, the geriatric, and the 15-year-old dog. How much does it need? Well, it needs different than what that puppy needs, right? And then if you have dogs with health issues like digestive problems of one type or another, or allergy problems or whatnot, the carbohydrate composition makes a difference. And so we can strategically work to try to make a better diet by knowing some of these things.
Yeah, and I think moving from the crude fiber to total dietary fiber in the label will
Oh, yeah.
be a game changing.
The fact that we stayed with crude for so long is just, it's unconscionable, really. I mean, it was, there's a paper, that paper was published in like the 1860s. And about 2 years after that paper was published, there was a paper about how bad the assay was. So we've known that for so long, yet in animal nutrition and human nutrition, they moved away from that long, long ago. Back when, fiber became important in human nutrition in the 70s. And it was recognized quite soon after that crude fiber was not the way to go. And then we did have the detergent fiber system back in there. And it was wonderful at measuring insoluble but not soluble. So thus all these total dietary fiber procedures came on board beginning in the 80s because human foods had so much of soluble fiber in them. And it was the soluble fiber that had a lot of the metabolic effects. The insoluble is basically for laxation. Okay. But the soluble fiber is the one that helps reduce blood cholesterol. It helps glycemic control. It helps immune function, that type of thing. And so we've taken the human is a wonderful model for dogs because the digestive tract is just exactly the same. There's no cecum. The relative proportion and length, the dog's a little smaller in large bowel than the human in terms of capacity. Relative to body weight, but human is a wonderful model for the dog.
Yeah, I know that's great. And if you don't have ileocannulated pigs, I think humans are for sure the best model because of the big cecum of the swine and different food intake as well.
Yeah, right.
Yeah. Well, hopefully we can maybe get some funding from those government agencies using dog as a model for humans.
That's
go
not
from
easy.
there.
They haven't been very supportive. The government hasn't.
It's always been a challenge.
Yeah.
We talk about a little bit about digestibility and using some other models for dogs and a little bit of cats. But how about the in vitro techniques? Do you think there is value in screening maybe novel fiber sources or carbohydrate sources for their fermentability using in vitros, or should we just go to a dog or cat trial first? What is the advantage of those in vitro techniques?
Well, the advantage of the in vitro, obviously, is that you can test a lot of things on the lab bench, and you don't have to. All you need is fecal samples to generate the inoculum that's necessary. I always say that in vitro is great for screening, and it's great for ranking, but it always gives better results than you're going to get in vivo. So if you test a prebiotic, let's say a potential prebiotic candidate, and you look at the microbiota afterwards, and you do all that type of work, it'll often show you, there's these wonderful changes and everything really looks good. Then you go to the animal, not so much, not quite as much. And so you have to be careful. You don't want to draw a direct inference from the in vitro, but if you're testing, let's say, any number of ingredients or any number of compounds that you're interested in putting in a pet diet, I think it's very effective in ranking those and in giving you an idea whether there's any reason to move forward. It can if you have bad in vitro, or if you have, let's say, very negative in vitro results provided the in vitro setup is good and everything, then there's not much reason to move on. But if you get some decent results, then in turn it helps with the ranking, and it'll help you decide, okay, you have 10 substrates. Well, I can't test 10 substrates in vivo, so I can test 3. It might be useful to decide on what those 3 are going to be. So I like in vitro. Of course, there's, as you know, there's so many in vitro. There's no standardization.
Yeah, and that's no problem.
you go from the 50 mil centrifuge tube, right, which gives you about as good a results as anything, to all the way to this TNO system that they have in the Netherlands, which is a computer run system that takes into account what goes in through the stomach and is simulated small intestine, and they've been working on the large bowel. I think they've got some kind of a system now, but it's very expensive, whatnot. But there are many in vitro systems.
Yeah, standardization is also a challenge across our discipline and many others as well. And so, since you have seen a lot of those techniques transition and changing over the years, do you have an idea about what do you think is next for fiber, or what is kind of the future of fiber in the next couple of years? And it's a very broad question, and probably nobody wants to answer this kind of questions, and I'm sorry for asking, but I was interested in hearing your thoughts on this.
Well, one of the things that we have to recognize is that a lot of people forget about is that we already, in the commercial pet food, we already have fiber, right? Have corn in the diet. Corn has about 10% TDF. Some of our pet diets have soybean meal. Soybean meal has 18% TDF. It has 5% galacto-oligosaccharides. So some of our, what we might call economic diets, already have a ton of fiber just from the natural ingredients that are there. So why would they need to be supplemented? Well, again, as you know, the industry, though, is moving toward what the marketers call premium and super premium. So a lot of times we won't find soybean meal in the diet. We might not find corn in the diet. They might use rice, or they might use some kind of animal protein in high amounts, that type of thing. So when you get to those kind of diets, then that's when the fiber profile needs to be evaluated very carefully. And so, and it's not today, it's not about one fiber. It's about what I think of as fiber blends. So you can put together different fiber blends to address specific health issues for animals or specific life stages for animals. And that's, I think, where the future comes in. The other exciting part is the prebiotic fibers, where you can use very low concentrations in the diet that have maximal impact, okay? Because they're very fermentable. They allow the good bugs in the large bowel to grow, and they make their own postbiotic compounds, that type of thing. So it's a matter now of understanding that. Then the probiotic area, the probiotics are so much better than they used to be. Years ago, probiotics were considered in animal nutrition. We call them, AFCO calls them direct fed microbials. They were kind of foo-foo dust, I mean, they'd be put in, and did they have a role? Who knew? Well, today, there's good evidence that there's some very, very good probiotic organisms and combinations of organisms. And I think the coolest thing that could happen would be for a true synbiotic to be produced that would be specific to the dog and specific to the cat. Okay, so again, if the listeners don't know, a synbiotic is a combination of the probiotic and the prebiotic. And we're not there yet by any means. We don't know exactly what probiotic organisms harmonize with prebiotic carbohydrates to produce a good effect in the animal. And I think that would be fantastic. I think that would allow a lot of good postbiotic compounds to be formed. And I think the animal would benefit greatly from that. So I think that's one of the real challenges and one of the real exciting opportunities down the road. And I think we can do that. We just don't need we don't need just FOS as a prebiotic. There are a lot of prebiotic candidates, we call them. They have activity on the microbiota, and they affect the microbiota. And we need to expand that list. because ISAP officially there's just three. There's fructooligosaccharides, galactooligosaccharides, and lactulose. And that list hasn't expanded. Now there's many other compounds that have prebiotic activity, okay? And we need to expand that list, and then we need to try to synergize the probiotic with the prebiotic. And I really do believe that could lead to some really good effects for the animal.
Yeah, that sounds very challenging, but also very exciting. So I hope.
Yeah, it is. But it's possible now, I think, with the technology.
Yeah. And Illinois does an amazing job with all the studies and investigations. So I'm sure there are going to be amazing things coming from there over the years. And I'm excited to learn more as well.
Me too.
It's time for our famous three.
Well, thank you, Dr. Fahey, for your talking about fiber and sharing your knowledge with us. I'm going to ask you some three last questions, if you don't mind. One, I gave some spoilers to you, so you had some time to think. But if you were not, research scientist on the animal science or nutrition area or side, what do you think would be? Have you ever thought about when you're a kid? I don't know if you had other dreams or hopes, or what do you think would be?
When I was a kid, I come from West Virginia, where the gas and oil industry are very prominent, and I thought about being an engineer because I really liked the. I was around those operations, and I thought it was the coolest thing. But unfortunately, my math skills did not match my my desire. I think I would have probably flunked out of college the first year if I had to take engineering. So I figured that out even in high school, that I don't think that this is going to work for me. So actually, I started college with the idea of being a high school biology teacher because And then I figured out, oh wow, I might be able to teach in college. What does that take? So anyhow, the engineer was the other career path, but that didn't. That
with
wouldn't
all
work.
the softwares that we have today, I think you will not need to do a lot of handing or
You still need to pass differential equations and calculus 10 and all that. So I don't think I could have done that.
The last two, since you have seen many grad students and people over the years, and most of them, I assume they succeed, but also there is always some people that don't find themselves in grad school. What do you think is something some students that may get caught up during grad school that may set them for failure, or not let them succeed as much as they could?
Well, I think the most graduate students that we've had over the years, and we've had a lot, have been highly motivated. I think if the one thing that some people attend graduate school because they want to be a veterinarian and they didn't get in. That in our business, that was the thing. So they're kind of waiting it out. And that's okay. I mean, sometimes it takes a year or two to get in. And I've had several master's students that went on to become a veterinarian. And I would tell them, and they were all very honest about it. And I said, okay, we can give you some research experience, but a master's degree is 2 years. And I expect you to stay for 2 years. And I expect you to write a master's thesis. And then I think you'll be in a good place to apply again, because you will take some more courses. You'll probably do good in those courses. And so that's worked out really well. I think anybody that's not honest about that they just join graduate school and then they jump off as soon as they get in vet school, that's not very, that's not a good thing for them or the professor, because there's a dishonesty there that they don't say, well, I'm going to jump out as soon as I get something else. But you kind of learn over the years, you learn how to figure out people's story and see if they're kind of being straight with you. I think one of the things, Julia, that as far as the mistake that some graduate students make is that there's some that stop at the master's, and they are so talented, and they could easily go on for a PhD. They don't do it, and they're going to hit the glass ceiling. One of these days, they're going to hit the glass ceiling, maybe in 10 years. Then it's too late because they're used to, they may be married, they may have a family, they're making a decent salary, but yet they've hit the glass ceiling. They can't go up any further. And they're kicking themselves because they didn't go on, they didn't take the extra 3 years, which seems like a long time when you're young, but looking back, it's like it goes so fast. And they didn't get the doctorate, where there's no glass ceiling for you. You can do whatever you want, and you can excel, and or not, but it's up to you. And so that's what I see. I see a lot of kids that did not go on. That I think later on they wish they had, and I'm not a lot of those people. Some are quite satisfied with what they have, but. That's the only real issue that I would see. Most of them are very hard workers. They're very into their area. They do very well. So I didn't have a lot of problem with that at all.
No, that's great. And I think sometimes you have to make some compromises in the short run to get, the long run results over time.
Yeah, that's right. You have to have the long view of the thing.
And it's hard sometimes, I think now it's even harder because you have so much distractions and opportunities that some people may got caught up on that.
Right.
And how about do you have, for a lot of successful people that you met over the years, there any specific traits that all of them they share, or, those people that, those are highly successful people, they have this trait specific that you think is common to them? And
well, I think the main trait is perseverance. I think you have to be persevering through life and the challenges that life brings. That if it's so that we all run into issues that are difficult, but if you can persevere through those, I think that's one thing I see in students today, that a lot of them used to be, many more of them were interested in academia. And today, it seems to me, this is just my observation, it may or may not be true, but so many more are interested in industry. And industry has a lot of good jobs. There's a lot of good opportunities in industry, and it's easy to understand why they would want to go into industry. In academia, as you probably already know from being there in Iowa State for a short while, like you say, there's so many things pulling you in so many different ways. You have to teach, you have to do some service, you have to do research, and there's all kinds of stuff that goes along with each of those responsibilities. And so in academia, you have to love what you do. I mean, you have to. You cannot be an 8 to 5 person at all. You have to really be into the area and not mind sitting down Saturday and working all day Saturday. That's just, it just is not a 40-hour-a-week job. And so if you like what you do, it's not work. But if you are worried about the time and all that, then probably it's not for you. And so with industry, they have more freedom. You have to work hard, certainly, but I think there's more time that you have of your own, that type of thing. You're not encouraged to work on the weekend. Matter of fact, they shut some of the places down. You're not even allowed back in your office during that time. And so, but both are. It depends on you. It depends on the individual as to what they want to do. And again, we're fortunate in nutrition to have so many opportunities. I mean, we have industry, we have academia, we have government, we have consulting, and there's jobs in all of this. Okay, there's jobs in all of these things, and some of our brethren aren't so fortunate to have so many opportunities within their field, and we remain blessed to have all those opportunities.
Yeah, and I think we are seeing more now. We probably have seen as well. There's more universities paying more attention to companion animals, so there are going to be probably more positions opening up over the years, and I hope people are passionate about academia and training the next generation. So, because you're going to need those people as well. So I hope people have those goals in life as well.
And universities today provide so much more help to the younger person. I mean,
yes.
When I started, I was thrown into the classroom within 3 months, and I had given a few lectures and seminars, and that was the extent of my teaching experience. Well, now you have workshops, and they have all kinds of help that they provide, and that's great. So you're not you're not thrown to the wolves anymore. They give you the tools that are necessary to be successful.
Yeah, and it's both ways. University wants you to be successful because they're investing in you. So
yeah, right, sure.
And there's a lot of mentorship and support. So
yeah. That's good. Yeah.
Well, thank you very much, Dr. Fahey, for accepting talking with me and sharing with our audience your knowledge. And it's an honor to be able to talk with you a little bit more with all your expertise and be able to be here with us today.
Thank you
very much.
All right. Take care.